the name.
Yes, sir. Yes, sir. Kumari Jodi.
Yes,
Kumari Jodi,
yes.
are
I
you
think you
listening?
have the list.
Yes, sir.
Please
Yes,
call.
sir. Yes, sir.
Yeah. At least 15
Kumari
minutes you
Jodi.
continue, then we'll.
Kumari Jodi.
Yes, sir. I'm present.
Yeah, please share your screen.
Okay.
Professor Som, hello.
Yes.
Yes, sir.
After 15 minutes, we will have a common session.
Yeah, that session we will continue at another link, the other link.
Okay. Yeah,
This
yeah.
is the
But
parallel link.
so you will drop this session, I think.
Yeah, I will be there.
No. That is the key.
No, it will
key.
not be dropped. Paper presentation will continue here.
Okay.
Yeah, paper presentation will continue here till the end, till we finish the paper presentation.
Okay. So someone is going to present. Okay.
Yeah.
Sir, is
Yeah,
it still visible?
Yes, it is
Yes.
visible. Please continue.
Good evening, everyone. Myself, Kumari Jyoti, research scholar under the guidance of Dr. Poonam Redu, Department of Mathematics, Maharshi Dayanand University, Rohtak, Haryana. Here is the abstract of my paper. In this paper, an extended carpooling model is presented by considering the vehicle's backward-looking effect based on collision sensitivity. We introduce the collision sensitivity coefficient into carpooling model. The performance of the model is investigated analytically and numerically. The stability criteria are obtained by linear stability analysis. We conclude that collision sensitivity substantially affects carpooling behavior and traffic congestion can be reduced by sensing the information of preceding vehicles. Here are the contents. Introduction, traffic flow modeling approach, carpooling traffic flow model, collision sensitivity, a model based on collision sensitivity, model derivation, linear stability analysis, conclusions, and then references. Traffic flow theory. What is traffic flow theory? Traffic flow theory is a mathematical tool that helps transportation engineers to understand and express the properties of traffic. Traffic flow is a study of interactions between vehicles, drivers, and infrastructure, including highways, signage, and traffic control devices, with the aim of understanding and developing an optimal road network with efficient movement of traffic and minimal traffic congestion. Traffic flow modeling approaches. There are three types of traffic flow models, which are microscopic models, macroscopic models, and mesoscopic models. Car following traffic flow model. The model of car following are the most suitable microscopic models to describe the movement of each vehicle. These models are based on the fact that drivers always react to stimuli generated by nearby cars. It is shown that such a reaction takes place with a delay time tau similar to the reaction time of drivers and according to some sensitivity for simulation. This behavior can be stated as reaction is equal to sensitivity into stimulus. Car following models reports the process in which drivers follow each other in the traffic stream. Theories of car following models describe how one vehicle follows another vehicle in an interrupted flow. Introduction to TTC and collision sensitivity. TTC, which is time to collision, is the duration of time before two vehicles collide if they continue at their present speed and on the same path. TTC is the main criteria in traffic flow theory. The mathematical expression of TTC is given as below. TTC is equal to xnt minus xn plus 1t minus lc by Vn plus 1t minus Vnt if Vnt greater than Vn plus 1t. Otherwise, TTC will be infinity. Where xnt and xn plus 1t are positions of preceding vehicles and following vehicles respectively. Vnt and Vn plus 1t are the velocity of preceding vehicle and the following vehicle respectively, and Lc is the length of vehicle.
Jodi, please excuse me. Make your presentation very brief. Okay, you don't need to read each and every line. Okay, make what is your contribution. You just explain that. That is sufficient.
Collision sensitivity coefficient. Collision sensitivity coefficient is just reciprocal of time to collision. Okay. Model derivation. The study of TTC and collision sensitivity introduced an extended carpooling model, which we call the collision prevention model, CP model, whose dynamic equation is given as dvnt by dt is equal to k v of delta xnt minus vnt plus lambda delta vnt plus gamma CSC into VNT, where K is the sensitivity. V of delta xnt is the optimal velocity function given by V of delta x is equal to V1 plus V2 tangent hyperbolic C1 into delta xt minus LC minus C2. Subs- Substituting equation 2 into equation 3, we have this equation dvnt by dt is equal to k into v delta x nt minus vnt plus lambda delta vnt plus gamma vnt minus vn plus 1t by delta xt minus lc into vnt. If we take gamma is equal to 0, then CP model is same as the full velocity difference model, whose equation is dvnt by dt is equal to k into v of delta xnt minus vnt plus lambda delta vnt. Here is the diagram of carpooling model in a single lane. In 2012, Sun developed an extended carpooling model, adding the driver's backward-looking effect on the basis of driver's perspective. The model control equation of the backward-looking effect model is dvnt by dt is equal to k into pvf delta xn plus 1t plus 1 minus p vb delta x nt minus vnt plus lambda delta vn plus 1t, where p is the probability of driver to pay attention to the information of rear vehicle. Vf delta xn plus 1t and vb delta x nt are the optimal velocity functions. The dynamic equation of the model considering TTC and backward looking effect dvnt by dt is equal to k into pvf delta xn plus 1t plus 1 minus pvb delta xnt minus vn plus 1t plus lambda delta vnt plus gamma vnt minus vn plus 1t by delta xt minus lc into vnt. Now we will talk about linear stability analysis of the model. To investigate the impact of collision sensitivity on the traffic on the stability of traffic flow, a linear stability analysis of the model was conducted. Let the uniform flow steady state solution be xn naught t is equal to bn plus pvfb plus 1 minus pvbb t, where b is uniform headway, vfb and vbb are corresponding optimal velocities. Let us assume that vnt be a small deviation of the traffic system. xnt is equal to xn naught plus ynt. Now we substitute the equation 11 into equation 7 and then putting these values, we finally get the values of z1 and z2. Therefore, the neutral stability condition is specified pvf dash b plus 1 minus pvb dash b is equal to half k plus lambda plus gamma pvfb plus 1 minus pvbb by b minus lc. When gamma is equal to 0, pv dash fb plus 1 minus pvb dash b is equal to 1 by 2 into k plus lambda. The neutral stability condition of the collision prevention model is reduced to the model of full velocity model. The traffic system will be stable if gamma is equal to pvf dash b plus 1 minus pvb dash b into b minus lc minus half k b minus lc minus lambda b minus lc by pvfb plus 1 minus pvbb. Here is the critical stability curve in headway and sensitivity space for different values of gamma. The figure shows the neutral stability curves with the help of stability conditions. The figure determines the headway sensitivity space of the full velocity difference model with lambda is equal to 0.5 and gamma is equal to 0. And the CP model with lambda is equal to 0.5 and gamma is equal to 0.1 up to 0.4. The region is divided into two sub-regions. One is stable region and second is unstable region. In this figure, peak of each curve corresponds to critical point. The upper part of the curve specify the stable region and the lower part specify the unstable region. As the value of gamma increases, the stable region increases. This shows that stability of traffic flow is elaborated by increasing the value of gamma. Further, CP model has larger stable area in comparison to full velocity difference model, which shows that collision sensitivity improves the stability of traffic flow. Here are the conclusions. In the study, we built a traffic flow model on the basis of full velocity difference model with consideration of collision sensitivity and backward-looking effect. We proposed the concept of collision sensitivity coefficient to include safety factors into car flowing model. Though linear stability analysis, a critical stability condition of model was obtained, the stable area of the traffic flow can be expanded by considering collision sensitivity. Here are the references. Thank you for your precious time.
Thank you, Ms. Jyoti. Uh, Due to the time constraint, we are unable to give the question session for the audience. Next, let me call Ravindra Kumar Sharma.
Okay, sir. Thank you, sir.
Please share your slides.
Yes, sir. Okay, sir. Can I start, sir?
Yes, please. And make
Okay.
your presentation as brief as possible.
Okay, sir.
Yeah, thank you.
Okay. Good evening, everyone. I am Ravindra Kumar Sharma. I am a research scholar in Thapar Institute of Engineering and Technology. Today, my present topic is the generalized hyperstability of functional equation in quasi-two-Banach space in International Conference on Nonlinear Applied Analysis and Optimizations. Uh, Firstly, abstract. In this paper, we study the hyperstability for the general linear equations in the setting of complete quasi-two-Banach space. First, we extend the main fixed point result of Rezek and Kapensky to quasi-two-Banach space. Then we use this result to generalize the main result on the hyperstability for the general linear equation in quasi-two-Banach space. Our result improve and generalize many results of literatures. Okay, functional equation is an equation in both side in which contains finite number of known functions and finite number of unknown functions with one or more than one variables. Stability of functional equation. Stability theory of functional equation mainly deals with following question. Is it true that a function which approximately satisfies a function equation f must be close to an exact solution of f? If there exists an affirmative answer, then functional equation f is stable. Furthermore, it can happen that there is no such alternative, that is, all the solutions of stability inequality are exactly the solution of the functional equation. In this case, there is a need of hyperstability. Stability of the functional equation rise by the question of Coulomb in 1940. In 1941, Haier applied the Ulam questions in the sense of Banach space. In 1950, Oki modified the Haier's results. Uh, in 1978, Rice's generalized the higher Ulam stability, and this stability is known as higher Ulam Rice's stability. In 1991, Gajda generalized the Rice's theorem, and in 1994, Grovetra generalized Rice's theorems, and this stability is known as higher generalized higher Ulam Rice's stability. In 2001, Masca gave the gave the hyperstability. Okay, now some basic definitions. Let X be a real linear space of dimension greater than 1 and this function be a real valued function on x cross x satisfy the conditions n1, n2, n3, n4, then this function is called two norm space and the pair is called two norm spaces. And if a quasi-two norm is a real valued function if it satisfies condition n1, n2, n3 and n5. The concept of quasi-two norm is given by C. Park in 2006. Also, C. Park gave quasi-P norm, which a quasi-two norm which satisfies this inequality is called quasi-P norm space. And concept of two norm is given by Gehr in 1964. A sequence xn is called quasi-two bounded sequence if there exists a positive real number m, xn comma z is less than m, and a sequence xn is said to be quasi-two convergent if there exists a point x belongs to x such that limit n tending to infinity xn minus x comma z equals to 0. A sequence is called quasi-two Cauchy sequence if there are linearly independent Z1, Z2, that is this, and a quasi-two norm in which every quasi-two Cauchy sequence is quasi-two converge is called quasi-two Banach space. In 2018, Brejdik and Kaplinski proved the following fixed point theorem in two Banach spaces. Let X be a non-empty set, Y be a two Banach space, and Z0 be the subset of Y containing two Li vectors this, and suppose a mapping this here Y to the power X means the set of all functions, a set of all mappings from X into Y is an operator satisfy the inequality 1, and assume the function psi epsilon and mapping phi satisfy the condition 2, 3, 4, then there exists a unique function psi of t for which phi x minus psi x is less than equals to this. Now, Park proved the following result, which will be used in this sequel. Let X be a quasi-two norm space, and there is a P is less 1 greater 0 is equivalent quasi-two norm, and this equivalent quasi-two norm. Using these lemmas and theorem 4, we generalize theorem 4 in the sense of quasi-two Banach space, which is my result first. In this, X be a non-empty set, Y be a quasi-two Banach space, and Z0 be the subset of Y containing this, and suppose a mapping satisfying equality 7 and function psi and phi satisfy 8, 9, 10, then there exists a function satisfying equality 11, 12, and 13 for some real number m, then the fixed point is unique. Now, in this section, we obtained hyperstability of general linear functional equation in the setting of quasi-two Banach space using theorem 7, which is my result 2 and main result. Let X be a quasi-two norm space over the field F, and Y is a quasi-two Banach space over the field K, and Z0 be the subset of Y containing two Li vectors. And second, Fx to Y be a function satisfy these conditions Lx, alpha u, lambda 1, lambda 2. And assume that the function Fx to Y satisfy the inequality 14. Then F satisfy the equation this. This is my result of hyperstability. Now, now consequences in this corollary, we take in inequality 14 ux z v y z is norm x comma z to the power p and norm y comma z to the power q, where x z comma y z is non-zero, then f satisfy the inequality this. These are my references, and thank you.
Thank you, Ravinder Sharma. May I have
Thank you, sir.
Mohammad Zaweh? Are you here? Mohammad Zaweh? Mohammed. Shall I call the next speaker? Oh, okay.
Hello. Dr. Shankar Raj.
Yes. Sir?
Who is presenting now?
This is by Mohammed Zaved.
Okay, Mohammed Javed.
Ah.
Then one more candidate and one
Yes, sir,
more
One
from
more
the
candidate is there. Chandramohan Bhuma
yeah,
is
that
there.
is from the session A.
Ah.
He will continue here, Bethu Srikant. And probably, I do not know the last one is there or not. Okay, please. Last two from session B also you call after this, after you
Yes,
finish
sir.
this one.
Okay, sir. Okay,
Yeah,
sir.
please.
Thank you, sir. Yes, please, Mohammed, you can start your presentation. So maximize your slides. Mr. Mohammed, are you hearing?
Sir, shall I present? My name is Srikant. Because I
It's
have some
Srikanth
work
Sri.
also. I'm waiting from the long time in the session.
No, in this session, your name is not here. This is the next one is Chandramohan Bhuma. That's all.
Yes,
Your
sir, I'm
name?
here, sir.
Ah, but Srikanth Sri.
Dr. Shankar Raj,
Yes,
after
sir.
Chandramohan,
Ah,
you will have Bethu Srikant from session B. He will be presenting here. Session A to session B.
oh, okay, sir.
In the
Okay.
list.
Ah.
Yeah. And probably Dimitri Iskanil may be present, may not be present. Okay.
Okay, sir. Okay.
So last two
Mr.
from
Mohammed,
session A.
are you ready? We couldn't see your full screen.
Rejoin. There is some problem.
Yeah. Okay, then shall I call the next speaker, sir?
Yes, if he
Ah,
is having some problem, then
Yeah. Sir, I'm available, sir.
yes,
Yeah,
please.
sure. Yes, sir, am I audible and my screen visible, sir?
Yes.
Yeah. Thank you, sir. Good evening to all. I'm Mr. B. Chandramohan, Faculty EC Department, Bapatla Engineering College, Andhra Pradesh. My
Okay.
paper is Parkinson disease detection from spirals and wave drawings using sequential model selection. This is basically a convolution neural network approach or deep learning approach for detecting Parkinson disease. So my presentation outline is as follows. What is Parkinson disease? What is the current state of the problem? Objectives of the work and the proposed algorithm, some simulations and results, and then conclusions. Parkinson disease is a progressive nervous system disorder that affects movement. Symptoms usually they start gradually and sometimes barely noticeable tremor in just one hand. Tremors are very common, but the disorder also commonly causes stiffness or slowing of the movements. That means hand stiffness and hand movement is basically limited. The main reason for Parkinson's disease is the changes in the dopamine activity in the brain, as the one slide of the brain is shown here. So basically, poor activity of the dopamine in the brain. So the symptoms of the Parkinson disease in the early stages, the face may show little or no expression. So arms may not swing when you walk. Speech may become soft and something like that. So this type of symptoms are seen at the early level, early stage of Parkinson disease. So Parkinson's disease cannot be cured, but some medicines there is a significant improvement in the conditions if proper medication is taken. Very rarely, the doctor will suggest a surgery to regulate certain regions of the brain. So usually the Parkinson's disease is seen at the age of 60, around 60 plus. It is usually observed in the old age people. And 10 to 20 years is the lifespan of the Parkinson disease patients after diagnosis. More than 8 million people are suffering with this disease globally. And in India itself, more than 8 lakh people are with this disease. In fact, this number is much higher than what I put here, 8 lakhs. So these are the stages of Parkinson disease. Developing stage 1, mild symptoms, but they are able to go about day-to-day life. So tremors and stiffness they start beginning to worse, and then poor posture or trouble in walking. So movement begins to slow down in third stage. Fourth stage, symptoms are severe, and almost fifth stage, walking or standing almost impossible at this point. So most of the times, these old age people, they are confined to a wheelchair or a bed. So what are the tests for Parkinson's disease? As such, there is no specific test for Parkinson's disease. So that's the reason why it is difficult to diagnose at the early stages. So usually the doctor will consider the symptoms of the person and may suggest some tests. One simple and effective test is handwriting and sketching, two simple checks for detecting whether a patient is suffering from Parkinson's disease or not. So in this approach, the suspected patient, PD patient, will be asked to write or to draw some text and spirals. So there are many approaches, but drawing spirals and waves is going to overcome the language barrier. If he is asked to write text, then the language barrier may come. If he is not literate, then he may not write. And sometimes the speech also is used to assess whether the patient is suffering from Parkinson's disease or not. Drawings of PD patients as biomarkers are more accurate in the assessment of the PD disease. Stiffness, bradykinesia, and tremor are the three motor symptoms responsible for poor handwriting or drawing of the PD patients. This is how the patient suffering from Parkinson's disease will be tested using a spiral-like drawing. You can see here on a paper, he is drawing the spiral and it is recorded and it is assessed. So on a tablet also. So a graphic tablet also used, and then this spiral drawing is used to assess whether the patient is suffering from Parkinson's disease or not. So the work here that I am proposing here is, yeah, right. So for healthy patients, the spirals drawn by healthy patients are left side, and patients suffering from Parkinson's, when they are asked to draw the spiral, the drawing is like this. So based on this, the model, the convolutional neural network that is trained is going to detect whether the person is having Parkinson disease or not. So here, both the wave drawings and spiral drawings are used. So this is how a wave drawing for a healthy person and a wave drawing for a Parkinson. In fact, this is severe Parkinson. So different wave drawings suffering by the patient suffering with Parkinson disease is shown here. The four images here, they show that one. So the goal of this, the current state of the problem is some researchers, they have used these drawings to identify the patient's condition. In fact, one work by Mr. Chakravarti, he has used CNNs, that is a convolutional neural network, a two-dimensional convolutional neural network for assessing the patient's Parkinson disease classification. And they have used linear regression and random forest classifiers as meta learners. And finally, an ensembling technique is used to detect whether he is suffering Parkinson disease or not. Now, the objective of the work is to propose an algorithm with improved accuracy, classification accuracy, using pre-trained convolutional neural network. Pre-trained convolutional neural networks are convolutional neural networks already trained on some other data set, not this data set, that is the Parkinson disease data set. Here, the data set consists of 55 patients' data, 28 patients with no Parkinson and disease, and 27 patients with Parkinson disease. So the problem is basically a binary classification problem. 1 or 2 images are there in each category of spirals and waves. 51 images in each classification, that is PD and non-PD, both spirals and waves. So the data set is a balanced data set. As such, there is no class imbalance problem. So this is a typical convolutional neural network where we have the input image, then convolutional layer, rectified linear layer, and then flattening layer, and then fully connected layer. Then we use these features here, and then we classify the image. For example, this image, whether it is a horse, zebra, or dog. And in this case, we supply the images of spirals and waves, and we identify whether the patient is having Parkinson or no Parkinson disease. So I used pre-trained convolutional neural network by using the transfer learning. So as I said, transfer learning is a learning strategy where the network is trained on one data, like ImageNet data, and it is used for some other data, like this Parkinson data set. These are the networks that I have used around 300 plus neural network, convolutional neural networks I have used. These are most of these neural networks are state of the art, the present convolutional neural networks, and there are wide varieties of structures also there here. Then the algorithm is the entire image data set is resized as per the chosen convolutional neural network here. Then they are normalized, all the images are normalized, and features are extracted at the last layer here. The features are extracted at this layer, flattening layer. So these features are used, right, normalized data set, and then pre-trained convolutional neural network. Features are extracted and they are given to the classifier, and then accuracy is computed. Now, I have used almost 300 plus convolutional neural networks for experimentation. So each convolutional neural network is tested for the classification accuracy, and it is kept aside. Then the higher, like that, all the 300 plus convolutional neural networks are tested for classification accuracy. The best one is chosen, the first one, and the remaining ones features are concatenated with the best one, and this loop is repeated 4 times. So that means the final feature vector is going to be a concatenated feature vector from the top in the sense of classification accuracy. From the classification accuracy perspective, the best performing 4 feature matrices are concatenated, and that is used ultimately for assessing whether the patient is suffering with the Parkinson disease or not. That's why all the CNNs, all the 300 convolutional neural networks are tested for the accuracy. So I have used the PyTorch framework. This is basically a Python-based deep learning library, PyTorch. And the repository that I have used is Ross Reitman's repo for all the pre-trained models. Google Colab environment. So Google has a free Colab environment in which we can do a lot of machine learning and deep learning models, classification, regression, and others. Most of the used pre-trained models that I have used here are models trained on ImageNet dataset. ImageNet dataset is having 12 million images on which the convolutional neural networks are trained. And some of the models that I have taken are trained on ImageNet 21K dataset. So that means more than 12 million images are there. In fact, it is more than 21 million images are there in ImageNet 21K dataset. So since the selection here or the selection is basically sequential one. So first one we choose the top one. Subsequent stages we test each and every model. We repeat all the 300 models, and whichever is performing the best after concatenation, that is taken as the second one. It need not be the best one amongst all the 300, but after concatenation, whether it is the best one or not. So that's why I put the heading as sequential model selection. So this process continues, and at the end, the feature size is going to be much higher naturally. But the computational aspect wise, since nowadays the computational power that is available in basically a cloud environment is not going to be a big issue unless it is deployed on a mobile architecture. So all the 323 models, the classification accuracies are shown here. These are the mean classification accuracy because we divided the data set into 80% to train and 20% to testing. That's how the model is to be tested. One, it is a supervised learning. So first training happens, then testing happens. So under that 80% training and 20% testing. So, but for both the spiral case and then wave case. So all the classifiers, for example, I've tested almost 30 plus, 20 plus classifiers like logistic regression, Ridge classifier, stochastic gradient descent classifier, KNN classifier. These are various classifiers available in the deep learning, or in fact machine learning terminology. Then whether the model is more general or not, that if we want to assess, then tenfold cross validation is a common validation. Tenfold cross validation is a technique where the entire data set is split into 10 folds. So 90 folds train, then that one fold is used for 9 folds used for training, one fold is used for testing. Whereas the second one, Luke V is leave one out cross validation. That means one sample we keep outside. The remaining sample, for example, we have 101 samples, 101 images. One image is kept aside, 100 images, the model is trained on 100 images, and we test it on the single image. So this process repeats for all the 101 images to have whether the model is more general or not. So that is the, in fact, is a good standard. Loop is a ultimate, but once the data size increases, this Loop becomes excessively computationally expensive. So that's why people go for tenfold cross validation, which is a gold standard in most of the machine learning and then deep learning algorithms. So if the folds are changed from 5-fold, 10-fold, 15-fold like that, how the mean accuracy changes is also shown here for both the spirals and then wave cases, because the patient will be asked to test both the spiral drawing and then wave drawing also. Since the feature vector size is going to increase, so we would like to decrease the feature vector size, and the most prominent dimensionality reduction techniques are employed. For example, principal component analysis, there's a principal component analysis, singular value decomposition, linear discriminant analysis, and other techniques I have employed by reducing the number of components. Now, with just 90 components, PCA is able to offer 95.4, and for a wave case, it is 96.8. So feature vector size is increased by concatenation and model selection. Then its dimensionality is reduced by using dimensionality reduction techniques. And receiver operating characteristics are the curves that are used to assess the performance of any binary classifier. So assessing true positive rate and then false positive rate. So ideally, it should be a vertical line. So this is a ideal case for a binary classification. It should be a straight line, because we want 100% true positives. We don't want any false positives. So that's why it should be a vertical line. So any deviation from the vertical line shows the performance of the suggested model here. So I've shown here it's almost vertical except this region. So I compared my work with one of the very recent work in 2020. So by Chakravarti, Parkinson's disease detection from spiral and wave drawings using convolutional neural networks, a multi-stage classifier approach. So there the classifiers are taken, different classifiers are taken, and then the ensemble technique is used. But here I have used different models, different convolutional neural network models. So compared to the work of the 14, that is Chakravarti's paper, the accuracy offered for both the spirals and the waves is much higher. And basically they have combined the both the spirals and waves in their work, that is the Chakravarti's work. So compared to the existing works, this way of concatenating by selecting the models in a sequential manner should improve the classification accuracy, particularly this Parkinson's disease detection. So to conclude, an improved Parkinson disease classification algorithm is proposed in this work. 323 pre-trained convolutional neural networks performance is assessed on this Parkinson disease dataset. This is the only dataset that is available in the literature. Fusion of the features is I highlighted, like increasing the feature vector size. What is the advantage? For subsequently, the feature vector size is reduced by employing dimensionality reduction techniques. So a new way of sequential model selection is proposed. So extensive simulations with the k-fold cross-validation and leave one out cross-validation is demonstrated, uh, showing the generalization of the proposed method. These are the references. I thank for patient listening. Any questions?
Thank you, Chandramohan. A really interesting work application. Thank you. Because of the time constraint, we couldn't
Yeah,
have
yeah,
a
I understood, sir. Thank you.
and I
Yeah.
would like to invite Shrikant Shri.
Yes.
Yes.
Please, uh,
Yeah, thank you.
please share your slides.
Okay. Is it visible, sir?
It is visible. Uh,
Is it clear?
yeah, please.
Yeah. Very good evening to you all. My paper is about ANN and RSM based modeling of Moningness tenopetala seed oil extraction. It is about the process of optimization and oil characterization. And coming to the abstract, this study dealt with an investigation of uh, physicochemical characteristics of Morinus tenopetala seed oil extracted by a solvent extraction technique using hexane as a solvent. And before the extraction process, the average moisture contents like crude ash, fiber, proteins, and oil contents of the seeds determined to be with rating values of 6.3 and 7.7, 2.7, 27.5, and 40.2 percentile respectively. And using the response surface method RSM and artificial neural network ANN, the extraction process was modeled. Based on the numerical solutions, the optimum process parameters were found to be particle size about 0.85 mm and temperature 85 degrees Celsius and extraction time 4.7 4.75 hours for maximizing the oil yield from the extraction. And in addition, the physical and chemical characteristics of obtained oil from optimized condition were investigated here. Coming to the introduction part, this work mainly focused on the extraction and the characterization of MSO by using the solvent extraction technology using food grade hexane as a solvent. Um, Moringa seed oil is well known to be highly valued in the cosmetic industry for its unique property of light and easily spreadness of on the skin. It is observed to be the best for massage and aromatherapy applications. On the other hand, MSO has a potential application in culinary. And about the related work, the present study aimed at determining the uh, physicochemical properties of moringa seeds and their extract oil of which cultivated at different regions in Egypt. And obtained results revealed that protein, lipid, ash, fiber, and total carbohydrate contents were in range of 34.51 percentile to 36.5 percentile and 28.62 percentile to 30.6 percentile, and respectively. And the results of oil physicochemical parameters were compared with those of commercial oils. And the previous papers focuses on characterizing the VSOs and USOs as fuels for the household cooking application using a modified pressurized cooking stove. And physical properties such as auto ignition point and auto ignition time, flash point density, and viscosity of VSOs play the vital role in the combustion. And in this paper, we have the proposed method with along with the RSM method, and we have the artificial neural networks for the comparison of the results based on the optimized parameters and particle size of the seeds, temperature, and extraction time. And some of the materials and methods we considered here, like chemicals, equipment, and materials, and sample preparation for seeds, and proximate analysis of Morgan's stenopetal seeds, and experimental design of MSO extraction, and a response to surface methodology RSM. And in this study, the influence of these chosen operating parameters like temperature, extraction time, and particle size, and output variable MSO yield, that is MSO yield, were evaluated using the RSM and using the RSM, the output variable, oil yield in percentile, can be represented as a function of the selected variables as a yield equal to P naught plus sigma equal to 1 to n, BIA into x plus sigma equal to 1 to n, Bij into x of I square plus sigma of I equal to 1 to n minus 1 and sigma j equal to 2, n into Bij xi, xij plus gamma and so on. And the extraction was carried out for predetermined combinations of chosen process parameters and temperature and particle size and time. And you can see the table here that determines shows the about maximum, minima, and average values of selected independent parameters that I had taken for this experiment, like temperature, fraction time, and particle size. And for the temperature unit is Celsius, and extraction time is hour, and particle size is millimeter. And the minimum temperature is about let's take the -1 value, and the temperature is about 68, and extraction time is 3.5 hours, particle size is 0.3, and average, if it is average, let's suppose take the value of 0, that is 76.5 temperature and 4.5 extraction time and 0.7 for particle size, and the maximum is 85, temperature and extraction time is 6, and the particle size is 1.2. The experiments were planned with the aid of design expert 7.00 by applying a box Benken design method. And in the second table, if you see, we have the factor T temperature and factor for the time hours and factor for particle size and with some different variables. And based on the combinations in each cycle, 10 grams of seed sample was taken to extract oil using 120 ml of food grade hexane solvent with a solid liquid ratio of 1:12. And at every end of each phase, the thimble was withdrawn from the setup and dried in the oven for 1 hour at 105 degrees Celsius. And the amount of the extract oil was determined by separating the final dried thimble with powder mass from initial thimble with seed powder mass. And based on the oil mass, the concentration of oil in the solvent hexane was calculated for each cycle of extraction. So that further the extract oil was stored in the bottle at the refrigerator for the analysis. And the parameters also taken to calculate the values of like oil yield, yield of oil, and also determination of physical properties of MSO, like moisture content in the extracted oil, and specific gravity, and kinematic viscosity, and acidity value of the MSO samples, etc. And here the ANN contains the great interconnected structures that comprises the countless handling components called neurons. So neurons are sorted out in various layers, which are also which are called as input layers, yield layers, and considered layers in this method. And coming to a few results about MSO extraction according to the BBD design of expert, and to optimize the extraction process, we considered the parameters, temperature, time, and particle size are grouped into different combinations, which are seen before the table, and all the combinations were examined using SOX head setup to extract MSO. Extraction was carried out in duplicated experiments, and also we have calculated the deviations and variances and the significance for a lack of fitness. We have identified it, and these are some values we have considered for the yield of MSO extraction. And also about the variance analysis of the variance of the model is considered by taking the parameters like sum of the squares and differences and mean square and f values and p value prob, etc. And these are some values we have taken for the time, maximum time and minimum time, and also for the uh, residual and errors and so on. And interpretation on a response surface plots, it is represented, yield is represented based on the preliminary BBD response surface methodology. RSM was employed to find the interaction effect and optimization of MSO extraction. Temperature T and time T and the particle size were three different the independent factors aiming to optimize for the maximizing the oil yield. And ANN method, we have taken the two layers for the first layer is for the optimization process, and second layer is for the bias, that is for the process. And modeling with the artificial neural network, so the expectations from the examining exploratory outcomes were taken in this table, like experimental value and a predicted value by the RSM and a predicted value by the ANN. And the experimental values and predicted values response on the yield percentile. So experimental value, if it is a 38.2, the predicted value by the RSM would be 39.17, and predicted value by ANN would be 39.16. And these are the few samples that were calculated based on the before expression. This And coming to the conclusion, the oil extracted using a solvent extraction technique from Morganstone and petala seeds was attempted. The oil extraction process was modeled using stochastic techniques, RSM and ANN. And the extraction process parameters, temperature, time, and particle size were optimized for maximizing the oil yield. And the oil extracted from the Morganstone and petala seed showed desirable properties. And according to the RSM analysis, the optimum process condition to extract the highest oil yield was found to be the combination of the following parameters: particle size 0.85 mm and temperature 85 degrees Celsius, and extraction time is 4.75 hours. And under this condition, the model predicted the oil yield was to be 39.5 percentile, and the physicochemical properties of the extracted Morganstone petal seed oil under the optimized condition were investigated and are characterized to be a successful source of edible oil for human consumption. And these are the few references you have mentioned, and thank you.
Thank you. Thank you.
Sorry for the issue that I have. I can present now my presentation or later.
Pardon? Can you
Good
present now?
evening. Muhammad Zawai. Can I
yes.
present now my presentation?
Hey, you can
Yes,
start.
yes. If you have not presented, then please.
I have some issue in the voice, but now it's okay, I think. I can present now?
No, you can present
Yes.
now. You can share your slides.
Yeah. Yes, okay, okay. Can I start?
Okay, yes.
Okay. I'd like to thank you first for giving me this opportunity to introduce this talk about on the complex analysis and geometry, and will be entitled Weak Solution to the Complex ACN Equation Associated to an M-Positive Current. In this talk, we will give first some preliminaries, and then we will discuss the essential singularity of positive current. Let's recall first the operator D and DC on an open subset of Cn, so that the operator DDC will be 1 over pi dd bar. If we take omega a domain in Cn, then a function is said to be plurisubharmonic if and only if it is upper semi-continuous and it satisfies the meaning inequality in every complex direction. As example here, if we take f an holomorphic function, then log of modulus f is a plurisubharmonic function. Also, for two plurisubharmonic function u1, u2, one has that the sum u1 plus u2 and the maximum is plurisubharmonic. And every plurisubharmonic function is in LP log for p greater than 1. As another property of plurisubharmonic function, one can see that the composition between an holomorphic function and a plurisubharmonic function still to be plurisubharmonic. So one can define the plurisubharmonicity on every complex manifold. A form alpha of p degree 1 in a domain of Cn is said to be M-positive if alpha power g, which beta n minus g is positive, where beta here is the standard color form of Cn. And a function is said to be M subharmonic if and only if all this is positive for all M positive form. Let's see here that if we take M equal to N, So every n subharmonic function is pluri-subharmonic. Now, if we take A closed subset, so A is said to be a submanifold of Cauchy-Riemann of dimension equal to K if and only if the tangent space at every point has a constant complex dimension equal to K, and this K is independent of Z. And one can see that a subset A is called analytic if and only if it is the intersection of zero of holomorphic function. Now we give the definition of current. The space of current of the dimension PQ is exactly the topological deal of the space of differential form over Cn, which are smooth and with compact support. So a current can canonically be written as this, where Tij here are distribution. If we take T a current of the dimension Tt, so T is said to be positive if all this is positive for every test function. And as a class of current, we have what we call closed current if dt is equal to 0. If the dct is positive, we say that T is plurisubharmonic, and if the dct is negative, we say that T is plurisuperharmonic. As example of current, if we take X, an analytic set, so the current of integration of X is positive closed current, and the product between a plurisubharmonic function and a positive closed current give always a plurisubharmonic current. We finish this section by introducing the notion of current of M positive if and only if T applied on beta n minus M, which alpha is positive for every M strongly positive form phi. Now we start the second section by giving the definition of the non-essential singularity. If we take A be a closed subset of omega and X an analytic subset outside A, so a point of this set is said to be non-essential singularity if we can extend X in a neighborhood of A to obtain a sub-manifold which is analytic with the same dimension. And we extend this definition to current, and we say that a point A is a non dct is less than a current positive, which is r. We finish this by giving the link, which consider the second main result, is that if we assume that all negligible sets with respect to the mass of T, then we could find a solution to the complex Monge-Ampère or Hessian operator. And thank you. Thank you very much.
Thank you. So I think, Professor, we have completed all the paper presentation, I think so.